We're going to move on. Hopefully we have everything synced up for our next speaker, who I'm super happy to have with us today. An architect who specializes in design for extreme environments. Guy Trotti has been an adventurer. He sailed around the world and explored remote parts of our planet. His passion for the environment and sustainability are what fuels his work, designing buildings, space vehicles, and even space suits. What you are about to see is an incredible cross-disciplinary transfer of knowledge between NASA and Dainese.
Well, this is going to be really hard to follow. This morning's speakers, this amazing conversation with Paolo from Baikonur, but here I am. Well, to me, I will tell you a little bit of my story as a designer, as an architect, and how I got involved in the space program. So, someone that hardly spoke English when I arrived in the United States in '69, right before the lunar landing, got inspired by all these guys and all this hardware, and and I'd push and push until somehow some little door opened until I got my foot in and never let it go. So these are some images that have always inspired me. On the right, the great American artist George O'Keeffe with her ladder to the moon. The kind of the allegoric image of the human want of going to space, of exploring space. And then the other one is Jim Lovell's picture, one of the first pictures of the Earth from the other side of the moon. As a matter of fact, Jim Lovell still holds the record of being the furthest man away from Earth on this orbit. And I had the privilege of meeting him about a couple of months ago. And he told me about this picture, about when he was in the capsule, he extended his arm and put the Earth behind his thumb, and realized at that moment that everything he knew, everybody he knew, everything he loved was fitted right under his thumbnail. And realized what we've been listening to Nicole and Dava and Paolo, how emotional this is, to realize how small Earth is and how much a spaceship Earth it is. So to me, great, inspiring, both in photography and in painting, what space brings to design. My story starts when I arrived in '69 to NASA, working on lunar bases, because at that time we had just had the first American space station called Skylab. It flew, 3 missions flew there, and 3 different astronauts in each mission. And the next step was going to the moon. And I, as an architect, thought that we could solve this problem and help NASA design this lunar base. And I was very lucky to be involved with NASA. I have been basically under scholarship or grants from NASA ever since, and looked at the designs for a lunar base. Then I worked on the space station, where we talked this morning about. I did some work in the space station, and through that experience, I would like to today tell the story of what it is to work in, as an artist, architect, designer, with scientists and engineers in space. That took me to extreme environments, all the way to designing the South Pole Station for the United States, winning a competition for building what it is now, a structure that is in the South Pole, not in the Antarctica, but actually the geographic South Pole. And actually experiment with NASA in these airplanes and different environments to simulate gravity. This is a photograph of the what we call, it used to be the KC-135, a big cargo plane. that we flew, and also known as the vomit comet, because it's most people have a hard time, holding things in their bellies when they're flying this machine, going from 0 gravity to 2 or 3 Gs and pulling up and down 40 times over the Gulf of Mexico to experience this magnificent thing that Nicole and Paolo tried to explain to us. So I was privileged to be able to experience little blips of what it feels to be in 0 gravity, so I could design and resolve some of the problems that we were thinking about for the space station. And so that's me on the South Pole, and then that is actually flying with Dava, and I've been the subject of many of Dava's experiments in this vomit comet, and she actually made me do that. Okay. So basically, this journey, and I call it a journey of design because I feel my whole life has been influenced by design. I come from a family of architects. I'm the 4th generation architect. My daughter is an architect. But looking at that past, looking at my great-grandfather's work in brick and stone in South America, and now, taking me to space, it's almost, I feel like I carry the baton, forward in our family. But that experience also turned me into designing as an industrial designer, because space is really designing hardware. The detailing, the quality of the materials are such that I always felt that it was like jewelry design. The inspiration of getting involved in this actually was when I saw for the first time the door of the Apollo capsule. If you look at the locking mechanism of the Apollo capsule, it is, to me, it was one of the most magnificent things I've ever seen in my life. And growing up with my father, going to carpenter shops to build wooden doors and hardware and beautiful craftsmanship, but I realized that this space door is the one that I wanted to design, and that's one of the great inspirations. So these are the areas that I have worked with in my career, and all because of space. So a little bit about the design process. I'm not going to bore you with this, but just to show in the ways that we work in our firm is really the understanding that we as designers cannot solve the problem alone. And as it was said this morning, the whole journey of architecture, design, translates and it gets inspired by science. And we need to really work in a very large table where we bring all this knowledge to solve these problems. So you're not working in isolation as a designer, as a maker, but really the idea of being able to understand the language of science, understand the language of engineering and technology without having the background and education. So over the years, this has been a journey of understanding languages, of what it means to work with engineers and scientists. And so very early in the game, in our design process, is we collect a group of people to solve the specific problems that we have at hand. So we include anywhere from, there was a question of psychologists. We work psychologists with anthropologists, and so everybody is around the table. And I think art is a big part of that. When we did a color study for the space station, at NASA was thinking about what are the colors that would help the crew live in a better environment. The Russians, for instance, and the Soviets at the time did a huge amount of work in this area. So, all these things are related to the psyche. How do you actually keep people happy and productive working in this space? So, anyway, the idea is that you put these people around the table, you discuss all the possible ideas, and then you start narrowing down and then building prototypes and rebuilding them until you get the right solution. So it is an evolutionary process. So this is the space station that we've been looking at this morning, and I had, again, the amazing privilege of working from the beginning of this project before it was called the International Space Station. I was lucky to be in Houston and working with the Johnson Space Center team to look at what the environment of these capsules would be. And for a significant amount of time, I worked 10 years on the habitation aspects of the space station. How the astronauts would eat, how they would go to the bathroom, how they slept, all the human aspects of it. You know, how the workstations would be, how they would operate in the zero gravity environment without gravity. Here we stand straight, and in space you're floating, your ergonomics change. So it was really a tremendous effort and you know, a privilege really to be able to, you know, participate in this amazing structure and in some of the modules of this amazing structure. As a matter of fact, you mentioned the Italian cupola, but we were working very early in the game with NASA on the cupola design, on how you might restrain yourself, how you might operate the arm from the cupola and so on. So there was some studies done on the cupola. But one of the aspects is eating in space. You know, we see the astronauts, you know, love to float food and like a fish eat, you know, of floating food. So we had this great study of how to design a kitchen. Basically, how do you store food, how do you refrigerate it, how do you package it, how do you cook it, and actually how do you actually make food in space. So this was a project that, again, it lasted for quite a while. Did a great study on the refrigerators because there's no gravity, so there's no convection. You know, like in our refrigerators here on Earth, you actually have to push the cold air through it. So, you know, we looked at waste, you know, and the most efficient ways to store this food. Anyway, again, from the packaging, how do they store them, keep them cool, and then eventually how to cook them. Again, if you have an oven in space, this is where the first injection ovens, the idea that you injected. Now we have convection. Convection actually was, we were designing these things in the 1980s, and now a lot of this has been commercialized. Some of the technologies that came from this project that I work with, ILC actually in Johnson, in Houston. But after all that design, this is the way the actual Galley looked in reality. And so we, at the time, we were looking at packaging, we're learning lessons from Skylab. You know, how do you actually eat in space? You know, because you can't just pick up the food and start flying around. So, you know, did a lot of the research in packaging. But this is how the astronauts look. But this is the time of communal time, because they're very busy during the time following their tasks. But at the time of the meal, when they actually can get all together, is a special moment to share the meal, the ritual that we have here on Earth of sitting around the table and sharing a meal continues in space. We're still humans, not because the astronauts go to space or planning to go to Mars, they become something else. We still carry our humanity, as we can clearly see by the two astronauts this morning. So potentially in the future, and we will maybe grow our own food. This is actually the astronauts in the space station, Kelly, that you saw this morning, growing a salad, a lettuce. So in the future, if we go to Mars, we probably end up growing a tremendous amount of food, not only for our bodies, but also for our minds, because I believe that growing plants is a very rewarding psychological experience, and you can tell that they're very, very happy, not only having fresh food, which is a real treasure in space, because you can't have fresh food all the time. So if we go to Mars, hopefully we'll have greenhouses that, again, provide this food, this feedback, this positive feedback, and also the oxygen that plants produce. So the possibility of assisting the atmosphere with replenishing the oxygen. The other area that I spent a good amount of time was designing was the sleeping quarters, which I call it a glorified telephone booth. You guys, the young ones, don't understand what a telephone booth means, but it was this little cabin that you get in to actually talk on the phone. They don't exist anymore. But that is Samantha Cristoforetti, the Italian astronaut, and in her sleeping bag and sleeping quarters. Again, this is the work that we originally did, and one of the things that we spent time working on was on the sleeping bags. So actually, this is very close to kind of fashion design, because you actually wear your sleeping bags. We actually came up with the original ideas of using the sleeping bags with arms to come out. So you are able to manipulate your computer and communicate maybe with your family. It is really the only private space in the space station that astronauts have, is the place where they can actually shut everybody out the day that they need to, and to sleep. And also the promotion of fabrics and foam. We had a critical part there, starting to look at how fabrics and these soft structures could serve as insulation and storage. So that takes me to the moon, a place that we still might go to in the way to Mars, and spending time looking at designing structures for the moon, whether there were inflatable structures. I was very lucky to work with Mike Bister-Fuller, and during my thesis, both undergraduate and graduate work, and looking at the design, or how we would design inflatable structures, lightweight structures on the surface of the moon, and using these at the time, very innovative fabrics, with Kevlar and Mylar, that they were very innovative at the time, and we just sent the first inflatable structure to the space station this year. So it's taken almost 30 years to go from an idea and concepts and promotion of these ideas to actually coming to fruition. But I think we will see a lot more of these inflatable structures. I think it would prove that is the way to go. Lately, I've been supported by NASA to think about other ways to populate or the architecture of the moon. And lately we've been thinking about these habitable rovers. So now the architecture is movable, which is true exploration. You actually explore the moon on these rovers, rather than having a base, which could be very costly, and then it limits you to a radius of exploration after a tremendous amount of investment. So the possibility of having a movable base, maybe a couple of these running together with 3 or 4 astronauts inside, and actually doing exploration to see if really we would build a base, where we would do it. So this was a great combination, I think, in terms of understanding the technology that it would require to design these vehicles, from the propulsion systems all the way to the ergonomics of the inside. How do you control the dust in the habitat, whether it's on Mars or Moon, given that you have a very light gravity? And maybe the dust is toxic. There's been some reports from the astronauts that went to the moon that had some allergic reaction some of the astronauts had to the dust. So very much involved in not only the aesthetics, but the mechanics of it. And now brings me to the work that we are doing with Dava. We were doing it before she assumed the role at NASA, but I'm still working with the laboratory at MIT, working on the spacesuits. And Dainese, which has been a great partner in this adventure. You see the prototypes here, which is a combination of Dava's science and engineering studies of these lines of non-extension, as she calls them, to understand how the skin moves. And this is a suit that actually is a second skin. Then I participate as the designer, looking at the ergonomics, looking at the mobility and the fabrics, and with Dainese making them and supporting the design by also translating all these designs into reality by using a very high technology. The patterns of the suits are made by computers. All the stitching is computerized and then put together by hand, but very crafty people, as well as the lamination of all the different fabrics, which we hope to even test more in the future. And then Vittorio will speak more about the other suit that also is work of Dava's lab and actually flown in space. So then the latest work on the BioSuit is we've been working on the helmet. How do you actually, because you cannot shrink wrap your head and wrap it like the Invisible Man, so you actually need air to breathe. And this is work that been collaborating with Michał Krasik. Michał, are you here? There he is, sitting back there. Can you stand up a minute? Michał has been the great collaborator, a great designer, professor in the University of Krakow, industrial designer. For all of you industrial designers, please talk to him after this work. What you see is his actual renderings, but we've been collaborating the ideas with MIT and the design of how do you actually increase visibility from the helmets that the astronauts wear today. This is a helmet more like a motorcycle helmet that you can move your head around, and it's attached, to the body in a very, very special way. We're still working on the mechanics of that. So, looking at really trying to revolutionize the whole idea of spacesuit design to create a more mobile, more like it's part of your body rather than you inside a vehicle, which is how it feels to be in the present suits. This is, again, work that we're doing right now with NASA. There's been injuries of the astronauts when they're training because they do maneuvers like they would be in space, so they're upside down and moving around their vehicle, their spacesuit. And there's been some abrasions and some discomfort that interferes really with their tasks. So we've been tasked to solve this problem. And this is an area, these are kind of the spot areas where there's been some injuries to astronauts. We came up with this idea originally of maybe having some inflatable pads that would lock the astronauts inside the suit, so now you're actually moving with the suit rather than moving your arm and then moving the suit. So this is, again, we recruited Dainese to help us with the design and the building of the prototypes, and we have 2 more years now of work to actually, these are the first prototypes that we built. NASA was very excited and actually just funded us for 2 more years actually to build the actual prototypes and test them in the swimming pools where the astronauts train. So this is very exciting work that we're carrying on right now. And the future for us as designers and your future is this area of deep space, the space between here and the moon. And this is what Dava talks about, the second phase of exploration with the Space Launch System, the big rocket that she showed the video about. And we're looking at small habitats where we have a small crew living very far away from the Earth for long periods of time. So we can learn maybe to live a week away from, the space station is about a day from here, or 2 days. We're only 300 miles above. These vehicles might go on the other side of the moon, closer to that environment. So we will be learning to live further and further away from the moon from the Earth as we approach Mars. And then eventually we will have to design vehicles like this where we'll transfer the crew for a year to Mars, then land habitat to the surface of Mars, and then come back in this vehicle for another year, maybe a year and a half, almost 3-year mission to go to Mars and back. So this is a very long, isolated experience, and where everything has to function well because nobody is coming to rescue. I think one of the greatest things that is happening right now, Dava briefly mentioned the makers, the 3D printers, and we've been meeting with folks that have a 3D printer right now on the space station where they actually can make a tool. If you need a part, you can make it rather than bringing it. So you cannot take all your parts with you. So the idea is to design the part or get the file to the space station, or you take it with you, and then you print it, make it, use it. And if you don't need it anymore, you can melt it and use the material again to build another part or another tool. So this is fascinating technology that we are starting to experiment with and looking at how we're going to use this fascinating technology. So, and to bring us back to the artwork of space, of what the universe gives us. This beautiful Earth, I cannot emphasize this, by living serendipitously, however you say that, as an astronaut, since I was 23 years old. Pretty much my whole life I've been looking at the Earth from outside, not in reality, but actually it is true that the astronauts and NASA and ESA and all the people that work and the thousands of people that work to make this possible, took me to space. I live literally in space through this extraordinary experience of exploration. And it's exploration that will not stop. These seeds were planted. We are a spacefaring civilization, and I really believe that we will colonize the moon and Mars. But most important, not to escape the Earth, but actually to look back, just like the astronauts do, to maintain the Earth. We have a responsibility because we could never, I always dreamed about, as an architect, how can I build the perfect environment for myself, to satisfy just myself? What would take to satisfy myself to live in space? And nothing could do what the Earth does. So there's nothing that we can do as humans that would come close to what we have here and how important it is to maintain it. Thank you.